Hello everyone, I hope you all are good and you all are practicing problems. Let us for now focus on this one. So in this question you can see the circuit and capacitance of each capacitor is indicated in the diagram. Fifth one is missing, so it is C actually. Okay. So this is this. What we have to calculate ratio of potential difference across capacitor 1 and 2. So this question we can simply solve by basic understanding of circuit, I would say, and also if you know isolated system case, then you can easily do it. जैसे suppose कर लो यहाँ से, I mean this is not a case of balanced Wheatstone bridge structure, right? Because this is C by 2C, this is 2C by C. So this is unbalanced case. And in that case, what will happen? Charge will be on this fifth capacitor also. Done it? So we cannot simply simplify the circuit, calculate charge and calculate charge potential difference and take their ratios. We cannot do that. So we need to go with basic knowledge of the circuit. अब देखो सपोज कर लो यहाँ से कुछ चार्ज आता है, लेट्स से Q1 plus Q2 charge is coming out of this battery and it is reaching here. Let's say Q1 charge is going this way and Q2 charge is going this way. अब देखो यहाँ से अगर प्लस चार्ज आप लेकर गए हो, यहाँ से आप क्या बोलोगे कि माइनस ऑफ Q1 plus Q2 charge is going this way. And if it will come here, minus Q1 charge will go where? So if you look at the symmetry of this circuit, आपको दिख रहा है यहाँ पे जब C है, capacitance C है, then it is taking Q1 charge. And here capacitance is 2C, it is taking Q2 charge. Similarly here, capacitance here is C and here it is 2C. I mean circuit जैसा यहाँ पे चार्ज को दिख रहा है, टोटल चार्ज को, सेम टोटल चार्ज को सर्किट इस पॉइंट पे भी नजर आ रहा है. डन है? So distribution will remain same. I mean here this side Q1 charge will go and this side minus Q1 charge and here minus Q2 charge will go. ठीक है? सो दिस बेसिक थिंग यू नीड टू लुक एट. उसके बाद आप देखो सी पे चार्ज क्या जाएगा. सो इफ यू लुक एट थिंग्स केयरफुली, जो तुम्हारा 1 का कैपेसिटर है, लेट अस रीड्रॉ इट, एंड 2 का कैपेसिटर and this is fifth capacitor, you just mark there these plates. So these three plates together are not connected to any battery, any external source which can supply it with charge, right? Nothing like that is there. So this is isolated system. And in the question, it is not said that these plates were initially connected to some battery and were provided with some charge. No, nothing. So we will say that initially it has charge of 0. Combination of charges on these three plates, 0. Finally, at any time also it will be 0 because this is isolated system. Done it? So let's say here the charge is something Q. So on this plate, what is the charge? Here plus Q1. So by the simple rule of capacitor, we know that if one plate has a charge of plus Q1, another will have a charge of minus Q1. Similarly, here it has a charge of minus Q2, it will have plus Q2. And if I'm telling it has a charge of plus Q, then Q plus Q2 minus Q1 will be equal to 0. So Q is equal to how much? Q1 minus Q2. So this is going to have a charge of Q1 minus Q2. Now we have distributed the charge. So how does it look like? It has a charge of Q1, it has a charge of Q2, this has a charge of Q1, this has a charge of Q2, and this one has a charge of Q1 minus Q2. Now we have to calculate ratio of what potential difference across capacitor 1 and 2. So 1 and 2 को आप ध्यान से देखो, इसके क्रॉस पोटेंशियल डिफरेंस क्या होगा? Q equal to CV formula you know, right? So potential difference across C1, that is across capacitor 1, will be equal to how much? I mean let's talk about V1. Let us write it V1. So V1 will be equal to how much? Charge across capacitor 1 or charge on capacitor 1 rather, Q1 by potential by C, right? So C is how much? C is C. So it is this. अगर V2 निकालना है, that is potential difference across capacitor 2, it will be equal to how much? Q2 by 2C. So somehow if we know ratio of Q1 by Q2, क्योंकि देखो V1 by V2 तुम्हारा क्या आने वाला है? 2Q1 by Q2. So if you know Q1 by Q2 ratio, we can easily write the answer here. And that we can do easily by using Kirchhoff's loop law, right? So let us traverse from here, point A. Let us move in this direction and come back to the same position. So when you will pass through this capacitor, you are moving from plus potential to negative, because this plate has a positive charge, this has a negative charge. So you are moving from higher potential to lower potential. So as you moved across capacitor 1, potential dropped, and that dropped by how much? Minus q1 by c. And when you moved across this, I mean, you are moving from, I mean, to this we have given positive charge, to this negative charge. So plus q1 minus q2 by c, because here potential is what? We are moving from which plate? Plus to minus, right? So yeah, high potential to low potential. Again, we need to give negative sign. Okay. And then when we are coming back here, this is positive plate, this is negative. We are moving from lower potential to higher potential. So basically we are gaining potential. We will say here plus. And this will be equal to how much? Q2 divided by 2C. Okay. And we know that sum of potential drop in a closed loop is going to be 0. So let us equate it to 0. And now Q2 by 2 is equal to how much? Sorry, यहाँ पे bracket ले लो आप, ठीक है? So Q1 plus Q1 minus Q2. And this is going to give you how much? I mean Q2 by 2 plus Q2. This is equal to, this will be equal to 2Q1. So this is equal to how much? 3Q2 by 2. So चलो next page में लिखते हैं 3Q2 by 2 is equal to how much? This is equal to 2Q1, right? So Q2 by Q1, we need to calculate that. No, Q1 by Q2. So Q1 by Q2 is equal to how much? 3 by 4. It is this. So potential V1 by V2 is going to be how much? 2 into Q1 by Q2. So 2 into 3 by 4. So that is going to give you 3 by 2 volt. Okay. So this is going to be your answer. So इस क्वेश्चन में बेसिक सर्किट का जो नॉलेज है ना, बिल्कुल बेसिक, उसको अगर आप यूज करोगे, you will be easily able to get the answer. I hope you have understood this question, but if you have doubt anywhere, you can always let me know in the comment section. Thank you. Take care of yourself. Bye bye.